Hello everyone, this is Miss Goldberry discussing an overview of the oceans and the world's oceans. In this unit there are some specific questions that we're going to be addressing and answering and discovering, such as where are the oceans, identifying the world's major oceans, waves, what causes waves, the ocean floor, ocean storms, currents, and tides. For the first part of this unit, our essential vocabulary are going to be including the following terms: temperature, salinity, density, ocean layers, your surface mix zone, the transition zone, and the deep zone, the conductivity temperature depth sensor, the major salts found in seawater, and black smokers. Another main component of this first part of the unit are identifying where are the Earth's main oceans. From the Arctic, the North Pacific, South Atlantic, and then also the Indian Ocean and the South Pacific Ocean and the Antarctic Ocean. Something you're going to be considering is, so what percent of the Earth is covered in water, and what percent is land, and what percent do you believe is salt versus fresh water? So these are some other inquiry-based learning that we're going to be doing. Now, this particular unit, the first part of the unit, when we're talking about oceans of the world, there some main points that you need to consider. And our mastery map is identifying what are the chemical and physical properties of seawater and what makes seawater so unique. You're going to be looking at salinity and the influence of density and temperature. And we know that seawater has very different properties than fresh water, and one of them is the chemical properties, what we call a salinity, and how these dynamics are distribute the different types of marine life that are found. And you can hear some of the marine life in the background. I'll tell you about that ocean sound you're hearing in just a moment. We know that temperature is an important physical property of water, and please do this brief animation that's going to be showing you about the distributions of the different temperatures of water. We know that, as you've learned previously, that seawater absorbs solar radiation that heats up the water, and this sun, as we know, our sun heats the earth unevenly. We know that oceans are warmer, of course, near the equator and colder at the poles, and that ocean temperature varies with depth. And salinity, we know, is a very important component of water, and it's talking about the percent of salt in water, and it's usually measured in parts per thousand, or PPT. Now, generally on average, this is an important number to remember. It's 35 parts per thousand, and of course different ocean surfaces vary in different salinities, and those variations can have different consequences for the type of life present. Now we know that water, like any other substance, has a density, which is the amount of mass per unit volume, and that the density of pure water depends upon its temperature. The colder the water, the higher the density, and of course until it freezes, and the maximum density of pure water occurs at about 4 degrees Celsius. We're going to be studying the differences between the two. Now, there's different zones in the ocean, and these zones have different temperatures and different densities and influence the type of marine life and organisms that are present. And generally, the structure of the ocean is a surface mix zone, which is about 0 to 200 meters. As you can imagine, because this has more influence to the sun, that the temperatures here are warmer. They have less salinity. Then the transition zone is from 200 to about 1,000 meters, and this temperature decreases with the surface mix zone. And I'm just going to show you what we're listening to really quickly. This is a wonderful film it's called Oceans. It's a film by Jacques Perrin and Jacques Luzzard. And I'll be sending you a link to this later. And what you've been hearing are these little mini videos about portions of their movie. And identify that marine life. The deep zone, so we have the surface zone 0 to 200, the transition zone 200 to 1000, and then the deep zone, which is greater than 1000 meters. This is the coldest, the saltiest, and the most dense of all of the waters of the ocean. And about 80% of ocean water incorporates into this deep zone. Now, these differences in temperature we know cause the surface currents, and because the Earth has an even heating that we observe in the atmosphere, this is also observed in the surface waters and the transition zone and the deep water zone of the oceans. And it creates these different currents that are found in the ocean. And we know that the surface waters is one way that help distribute heat around our Earth. And these differences in density drive the currents in the deep ocean as well. So please look at this interactive video on the deep currents. And this layering of life, this layering of temperature, this layering of density influences the myriad of marine life that's present. For instance, there's only very specific types of marine life that can tolerate living in the extreme density and salinities and cold of the deep zone, versus there's only certain types that can be found in the transition zone. Again, this mastery map will be very helpful for you for section 2.1, where you're identifying the differences between what the chemical properties are, what they influence. Of course, the salinity influences the density, and the marine life that's present, the physical properties of temperature and density also influence the density of the layers, the currents in the layers, and then also the marine life that's present according to the type of density or the temperature that's present. In addition to these essential vocabularies, just a reminder that you can also contact me. Our office hours are Monday through Thursday, 8:30 through 9. The small groups are held for us Tuesday through Thursday, 10 to noon, or you can give me a call if you have additional questions about the beginning of Unit 2. All right, I hope you're going to enjoy their spectacular inquiry into our exquisite and dynamic oceans.